Generative Components tutorial. Today, we'll be placing some geometry, exploring some of the options available, and how we can interact with both the elements in the view as well as in the graph window. So let's get started. Here we are in a fresh DGN file, based on the standard designseed.dgn. Let's place a point in view 1 using the point tool from the ribbon bar. Clicking on the point tool will trigger a pop-up asking if we would like to create a coordinate system. This is due to the default placement option for the points requiring a coordinate system. The dialog is also asking if we'd like to set up this as the base coordinate system, which as suggested is called base CS. Let's click yes to this dialog, and then we're asked which model we would like to place this in for our given file. As we only have one model, we can just click OK. Now you can see we have the base CS in our graph window, and if we zoom in you can see the coordinate system has been placed at the file 0, 0, 0. Now we're ready to place our point in the view. We can click anywhere in the view and you can see the point appear, and the corresponding node will also appear in the graph window. Hovering over the XYZ translations, you can now see that each point has been populated the word free and the exact numerical location in each direction. Free is to indicate that this is not fixed and can be moved around in the view using the move tool. Now if we were to place a point node by clicking and dragging from the node types palette, it would default to create a point with the XYZ values at 0, 0, 0. If we change these values to say 500 for the X and Y, you can see in the view the access lines for the X and Y have disappeared. And if we change the Z value to 500 as well, you can now see that the access lines have all disappeared. And we have a yellow dot in the view indicating we have a point and that it is constrained to the defined values. This is in comparison to the first point, where we can select the move tool from the ribbon bar and click on say the X axis and freely move the point around the view. Whereas this is not possible with the second point we created. Now if we wanted to remove this second point, we can't simply select it in the view and press delete. Selecting it in the view will also select it in the graph window, which is a good way to identify the node responsible for the point. But if we want to delete the point, we can select the node and click on the delete submodel button on the ribbon bar, or simply right click on the node and select delete. Now let's have a look at placing some simple geometry. First, we should head over to the transaction tab and we can see we don't have any transactions. Let's fix that by clicking on the play button to populate the list with the current nodes we've created. Now would be a good time to click on the auto record button if you wanted to be sure every move you make is saved. So let's click on the node types palette again and let's place a circle node. When the node is placed, you can see that it has automatically named itself circle 1. And this will increment every time you place a new circle node. Or you can just change the name to anything you'd like, unless it is already used in the graph view or it is taken up by a tool or a process within GC. If you try to name your node, say point, GC will respond with a warning asking you to choose a different name as it is already used. One rule, however, is not to leave any spaces in your name. GC will return an error that is not allowed. Typically, I try to use Pascal case for the names as it makes it easier to read. The node is currently in construction mode as shown by the little worker at the bottom left of the node. But for now, let's look at the drop-down list at the top, and we can see there's a large list of methods available for placing a circle. When you think of placing a circle in, say, MicroStation, you have a number of methods, by center, edge, or diameter. You can think of this list as the same thing. What method would you like to define the circle? You can see here there's a lot to choose from. The default is center start plan point, and there's circle offset, by points on a circle, by tangent to 3 curves, scribed in a triangle, but for now, we're going to select by center and radius. When you select a new method, the required input will change to suit. With this method, we're now asked for a center point, a radius, and a support. The center point has automatically been linked up to the base CS. We may not want that to be the center point, so let's right-click on that wire and say disconnect from the base CS, and we can connect that up to the dot on the right of the point 1 node. With nodes, the inputs are on the left and the outputs are on the right. So now for the radius, we could connect that to another node, or we could just type in a number. So for now, let's just type in 1000. The last input required is the support. If you hover over the input, it will give you some information about what it is expecting as an input. It is indicating it's looking for a support plane for the circle, and the type of input is I-plane. And it gives some examples of I-planes that it accepts. We can think of planes like the XY plane. A typical input might be a coordinate system, the XY, XZ, or YZ plane. To make it even simpler, we can click in that input box and select the plane we'd like in the view, and it will be automatically populated in that input. So pressing enter to accept, the circle is created. You can see the new linking wire has been added between the base CS.XY plane and the circle 1 node. Now if you wanted to change the plane, we could simply select it again, or if we wanted, we could just adjust the text in the input field. And if we change that, we can see now we have a circle based on the YZ plane. So let's change that back to the XY plane. And to make things a little bit easier for anyone using the file, let's drag in a value node to control the radius. Here we can rename this to my circle radius and give it the value, and then simply link this up to the node input. Now we can make changes to the value node, and the circle will update automatically. The power of GC is not just creating a single point and circles, it really comes from multiple connections. Let's place some more points in the view. And we can select and move the nodes around in the graph window to make them a little bit easier to read with the inputs on the left. Now if we wanted the same circle on both the new points we just created, all we need to do is drag a wire from the output of the points over to the input of the circle. Now we have 3 circles that will update whenever we change the Maya center radius value. For now, let's select the points and the circle node and right click and turn off their visibility. Let's try another node. First, let's place 4 points anywhere in the view using the point tool from the ribbon bar. You can see the nodes are placed in an awkward position on the graph. Select those new points and drag them down below the existing nodes, so it's a bit easier to see. So now let's drag in a polygon node into the graph, and zooming in a bit to see the node itself. And now you could change the method of placement, but for now, by vertices is the default, and that's the one we need. We can now click inside the input box and drag a selection around the points in the view, and the input box will automatically be populated with all of those points. And the advantage of this is they're all correctly formatted with curly brackets and commas. Clicking enter and the polygon will be created. Now this is a simple 2D polygon, but we can use this to get a bit of data. For example, we can drag in a value node, and if we click on the down arrow on the right of the polygon node, we can now see a list of possible outputs. A good one might be area, so let's pin out that one for now, and we can link that up to the value node, and it will display the area of the polygon. So while we're looking at the node dropdowns, let's take a look at the dropdowns for the input. And here you can see there's some additional inputs that are not pinned out by default, and some might come in useful later on. For example, the polygon has an input for force planar. Double click on the node, it will open up a larger dialog that will show the inputs which might be easier to see. Looking at the technical inputs, there are specific ones to this node. There are also catalog item and part lists for additional information and drawing symbology. Along with the technical inputs, there are some general inputs that are available on all nodes. Here you can see things like color, fill color, or level names. For now, let's change the color and turn on the fill and change the fill color. And we can see it's updated in the view. Now let's look at placing another node. Let's place a solid node by dragging that into the graph window. The default method is offset from closed curve, which is the one we'll use for this example. The first input is closed curve to offset, which we can link up to the polygon we just created. But first, let's set the offset below and offset above values. And finally, let's link up polygon 1 to the input on the solid, and you can see a solid is created. With this action, GC is helpful and hides polygon 1. And if we change the display style, you can see it a bit easier. For now, let's change back to the wireframe as I found this a bit more responsive. And let's take a look at the other outputs for the solid node. So dragging in a value node to display something for us, we can see in the list there is the standard area and volume, as well as some other items like mass. But for now, let's just pin out the volume and link it up to the value node. So if you wanted to use this value in some way in another node, there is no need to pass it through a value node. You can simply just directly link to this output on the solid node. This is just an aid to see the value ourselves. We can, however, also put in some other math operations in the value node to display the value, say in cubic meters rather than cubic millimeters. For now, let's hide all the nodes associated with this, and we can run through one final example. I'll place some more points in the view that will be our controls for a B-spline curve. We can select them in the graph window and arrange them. Dragging in a B-spline curve node, we'll change the input method to by points rather than by poles, as this is the way to force the B-spline to go through the points we've just created. Clicking inside the input box, we can select the points in the view and clicking enter. Now, as you would expect, if we move any of the points, the B-spline will automatically be updated. We can rotate the view a bit so we can see the B-spline curve a bit better, and we'll drag in a B-spline surface node, changing this surface to surface of projection, linking up the B-spline curve 1 to the curve to project input, and setting the offset above to 2000 and the offset below to 0, we can see the surface is created, however, is projected down rather than up. Probably not what we expected it to do. But this is common with dealing with B-spline curves in different directions. But this is an easy fix. We could simply swap the inputs over to make it go in the opposite direction, but if we had multiple B-splines that were running in different directions, it'd be annoying to try and set all of those up. There is, however, an additional input available in the node. Click on the down arrow on the inputs and pin out projection direction. Now if we click inside this input, we can simply select the base CS.Z direction, and that will indicate which direction is up. And now we have the offset heading in the correct direction, and this will be consistent regardless of any B-spline direction. Finally, we can drag in a solid node and change the method to offset from surface, link up the B-spline surface, and input some values for the offset above and below, and we have a solid. So in this video, we've looked at a small portion of the available geometry nodes, but hopefully now you have an understanding of how they work and can start exploring the different node types and how they are placed. In the next video, we'll start looking at how to utilize existing geometry, 2D or 3D, as a starting point for our GC scripts. Thanks for watching, and we'll see you next time.